So we talked about implementation of a stack using arrays and linked lists. Now let's see how this is done in C++. So first see how we can implement a stack using array. As mentioned earlier, so first we have to know exactly how many elements we have and find the maximum size of the array. So this is, let's say, like the maximum size of our array is like 1000. We have so like I implemented this in a class, so basically encapsulated this in a class. So we have the class stack, we have a member variable called top. So if you remember, like we initialize this top to be -1 for any stack that we have, and it's gonna store the index that we're gonna that's gonna represent the top of the array. We have an array of size max. This is possible because this is a constant number. Otherwise, we couldn't have a variable as the size of a static array. Well, some compilers allow that, but mostly it's not possible. We have a constructor that initializes top to be -1. You know the reason behind it, because this means that we're going to have an empty stack. We have push, pop, peek, and is empty member functions or methods. The push one, so these are like the function declarations, and now we have the definitions. The push one, what we have to check first is that have we exhausted the array? Like basically means that is our array full or not full, right? So how can we check that? If the value of top is equal to max -1, that means that our array is full. So if top is greater than equal max -1, or like equal max -1, that means that we can't push anything. So like in this case, we can just like give a message to the user, stack overflow. What I want you to do in the exercise that I have put in the next slide, I want you to replace this one with throwing an exception. If our array is not full, it means that we can insert or push a new element. So in that case, first we have to increment the top and then push the value that we want to insert in the stack into index top of the array A, which we just incremented. So that's I hope that you guys remember the difference between pre-increment and post-increment. This is pre-increment. So we are incrementing top first and then inserting x into a top, copying x into a top. Here we just also print a message for the user so that it knows that there was an element pushed into the stack. For the pop, again, we have a checkpoint. We have to make sure that our our stack is not empty. So the stack is going to be empty if top is equal to -1. So if top is less than 0, what we do, we print a message. We let the user know that it's going to be underflow, so we can't pop anything. Now the difference between push and pop is that pop has to return an integer, right? It has to return the top of the stack because our stack is a stack of integer, a pile of integers. So it has to return an integer in this case. So we have to return something. So here we are returning 0. This is not a perfect code. Why this is not a perfect code? Because how is the user supposed to know that this 0 that we are returning is an error code or is actually what it was in the stack? It was number 0 that was in the stack. Well, we are printing a message, but a better way of writing this would be throwing an exception, which is something I want you to think of, and I want you to work on it. If the stack is not empty, we save the value of a top in a temporary variable, then decrement the top and return that value. Okay, so in this case, our top is going to be decremented. It's basically moving towards the left. I could replace these two lines with just saying return a top minus minus. It would have been the same. The difference between top and peak is that like we don't have to, well, like we have to check if the stack is empty or not, but we don't have to decrement. We shouldn't decrement because we don't want to remove an element. We just want to see what's in the top. And the is empty is pretty straightforward. If top is less than 0, this is gonna be true, so we're gonna return true. So if top is -1, our stack is empty, so we're gonna return true. If it's bigger than or equal 0, we're gonna return false. It means that our stack is not empty. And this is a driver code for it. As a class exercise, I want you to modify this code. One thing I want you to do is, first of all, add precondition and postcondition for all the functions that we have here. So precondition is basically the assumptions that we should have when we call a function. So like what is true, what should the user or like whoever runs the code make sure that's true before the function is called. So that's going to be precondition, and postcondition is what's going to happen after the function call. So add precondition, postcondition for all of the functions. Use exception handling, so throw an exception instead of what we are doing here. Make the class templated. So this is a pile of integer numbers. So our stack, it's only going to work for integer numbers. So what if I want to have a pile of doubles or pile of characters or pile of strings or pile of like students or pile of bank accounts? It's pretty simple to make this class templated. You just like have to add a line here saying template class T in angle brackets, and then you can replace this one with T, which is going to be the data type or type name that we're going to use as basically something that can be changed when we instantiate the objects of class stack. So adding a line here, making a change here, the rest of them should be straightforward. But this might, like you might have, like you definitely have to change this one. You have to change like things in the functions. And like when you instantiate an object of class stack, you have to specify what this type name is going to be. So is it integer, is it character, string? So that's one thing I also like want you to implement, and provide modularity by separating separating this class into a CPP file and a header file. So ideally we want to have two files for each class, a header file and a CPP file. In the header file we will have the class declaration, and in the CPP file we would have the definition of all the member functions. Also, as a practice, you can implement other member functions for the same class. Is full, count, change, display. Is full is very similar to is empty, just checks that the stack is full or not, is the array exhausted or not. Count would basically count how many elements or how many elements you have in your stack, how many of the elements of the array you have used in the stack. Change would have a parameter, and you would change a certain point in your stack to another parameter that you pass to this function. Display would display all the elements of the stack from top to the bottom. Okay, or from bottom, from yeah, from top to the bottom, or from bottom to the top. It's like your choice. Then the next thing that we're gonna see is how to implement a stack using linked list. I haven't encapsulated this one in a class. This is something I want you to practice, and I want you to do it yourself. So everything that we see, all the functions, push, pop, peek, they're non-member functions. It's pretty simple to do it, similar to how we did it for arrays. You just like have to have a class of a stack. You would have a member variable called top, which is a pointer to the node. You initialize it with null, because whenever you have an empty stack, it means that the head pointer is going to be null. The push member function, as mentioned earlier, we need to have a temporary pointer, which is going to point to a newly allocated node. First, we have to make sure that we don't have bad allocation. So we have to make sure that the heap is not full. We do that here. Then we insert or push the argument that's the one that we want to push into the stack. We make the temp arrow data equal to this data. We make the pointer of the newly allocated node point to the previous top of the stack, and then we change the top to temp, okay, as mentioned in the previous video. The isEmpty1 is pretty straightforward. If top is equal null, it's going to return true. Otherwise, it's going to return false. The pop function, we have a temporary pointer. Using this temporary pointer, we make this temporary pointer point to the top of the stack. We move the top to the next node in the stack, or to the null if you only have one node. And we have to return the data of the top of the stack before removing it. So that's why, like, I'm using a temporary variable here. I store the data part of the previous top of the stack into a variable m. I delete the previous top and then return m. Okay, so I forgot to mention about this temporary variable in the previous video, but because like we have to delete the previous top of the stack, we have to make sure to first store the value that has to be returned in a temporary variable, and then after deleting it, we would return it. The peak part, it just like doesn't have the deleting part. We don't need the temporary, we don't need any temporary variable, so we just return the top arrow data, because the difference between pop and pick is that like this one, it's supposed to fetch and remove. This one only fetches. The display part would just display all the data stored in the linked list, so it traverses through the linked list from head to the bottom, or from head to the tail, from top to the bottom. Okay. Again, as a practice, what I want you to do is encapsulate this into a class, into a templated class, provide modularity, implement exception, add precondition, and post condition. Okay, and we already answered this question. Why did we consider head to be the top of the stack and not the tail? So the advantage of linked list implementation is that, like, if you remember, like in the array implementation, we have an array of size 1000. Are we going to use all of this? Probably not. So there's some like unused memory spaces. And what if we want to go over 1000, right? Then it's not possible using a static array, so we have to do dynamic array. So we have to have something called growable array, and we have to basically deallocate this array, copy this array into a newly allocated array with a bigger size, and deallocate the previous um, array that we have. So it's a little bit of work. It's too much work actually. So like you either like would lose some memory, or you have the need to deallocate and allocate, which is not ideal. So the linked list implementation would be more efficient. And also like wanted to mention that it is possible to do the array implementation using dynamic array, and make it bigger, or make it bigger like as needed. So this is a link that you can follow to see how this is done using dynamic arrays. In the next videos, I'm going to show you some um, application of stacks. So how to reverse an array, or how to reverse a linked list using the stacks. How to check for bracket imbalances in a string using stacks. How to evaluate a postfix expression using stacks. How to convert infix notation to postfix. How to solve Tavarov-Hanoi using the stack. So these are coming next. But maybe you can try them yourself first before watching the next videos. Also, one thing I have to mention is that we already implemented the class stack using array, and I asked you to do it using linked list, so by encapsulating this into a class. The standard template library of C++ already comes with a class stack. Okay, so and it's a templated class. So like we don't have to implement our own class of a stack, but for this course, want to make sure that you guys are familiar with how this is done. And if you include the stack library, you can just basically instantiate any object of this class. Because this is a template class, you have to make sure to specify the type name or data type, and this just like has all the operations that are needed, like push, pop, empty. So like this is gonna check if the stack is empty or not. That's all for this video, and more videos will be coming soon.